Okay, so we're going to look at question 7 then now. And as usual, we need to read it carefully. So in triangle ABC, the vector A to B, so that's this vector here, is going to be negative 3i plus 6j. And the vector from A to C is 10i take away 2j. And that's that vector there, A to C. So find the size of the angle BAC. So if you've got to find the angle of BAC, that is the angle at A. It's the corner at A here, so it's that one that we need. Now to find the angle in a triangle, you need to know the length of all three sides. So we need the length of all three sides is the key as the way into the question. So the magnitude of AB is equal to, well, we can use Pythagoras for that, negative 3 squared plus 6 squared. We've assumed that I and j are perpendicular. That's a fairly standard assumption. So I is a unit vector perpendicular to the unit vector j. So we've got a right angle triangle there using the vector 3i plus 6j. Minus 3i plus 6j, so the magnitude then is the square root of 9 plus 36, which is root 45. What's the square factor 9? So we've got root 9 root 5, so that's 3 root 5 for AB. For the vector AC, magnitude of that, we've got 10 squared plus negative 2 squared, square rooted. So that's the square root of 104. So square factor there looks like it's 4 times root 26. So we've got 2 root 26 for that. Okay, now we're also going to need to find the third side, so that's BC. So we know the vector BC is equal to minus the vector AB plus the vector A to C. So to get from B to C, I'm going down this route, negative AB plus AC. That's what we've done. So negative AB is the negative of negative 3i, negative of negative 3i plus 6j, plus AC, which is 10i minus 2j, 10i minus 2j, which gives us 13i minus 8j. Okay, but we don't just need the vector, we need the length of that. So the magnitude of BC is equal to 13 squared plus negative 8 squared, which equals a square root of 169 plus 64 equals 233. 233, I said, didn't I? 233 as the length of that vector. So we come up here, we've worked out that length is root 233. That length is the square root of 104. And this length here is the square root of 45. I've simplified those down out of habit where necessary. Okay, so to find the angle, we're going to use the cosine rule. And again, you need to learn this, or you should be familiar with it. Learn cosine rule. A squared equals b squared plus c squared minus 2bc cos of angle A. And we're working out angle A, so that's exactly the form we like. So A squared. Now A, little a, is going to be the side opposite angle A. So that's A, this will be side little b, this will be side little c. So we get, substituting it in, the square root of 233 squared is equal to b squared, which was the square root of 104, root 104 squared, plus c squared, which was root 45, so root 45 squared. Nonsense, why am I doing that? Minus 2b, which was root 104, root 45 for c, cos of a, which is what we're trying to find. So that gives 233 is equal to 104 plus 45 minus 2 root 104, 45 cos of A. So cos of A is equal to, rearranging this, so you add this chunk across to the left-hand side and then divide by the multiple of cos A, which is 2 root 104 root 45, and on the top we've got the 104 plus 45 minus 233. So let's tidy that up. On the top we have got 149 minus 233 is going to be minus 51 plus 33 is 84 over 2. 104 we then wrote, root 104 we wrote as 2 root 26 times 2 root 26 times root 45 was 3 root 5 times 3 root 5. So 2 times 2 times 3 is 12. 12's into 84, go 7. So we've got minus 7 over the square root of 5 times the square root of 6, or the square root of 130. Just depending on how we want to write that. Okay, so A is equal to arc cos of negative 7 over root 130, and we get, tap it in the calculator, 127.9 degrees. Part B. Find the exact area of the triangle. Notice the word exact there in the question. Yeah, so if it says exact, you've got to think, do without a calculator. Do without using a calculator. Yeah, that's really how we should be approaching the question. So, area of the triangle, part B, area of triangle is equal to a half AB sine of C. Well, that should be relatively straightforward. We go along half. We should know that for that, use that rule, what we need is two sides and the angle in between. And then this third side, it doesn't matter whether we know it or not. So if we're doing it with an angle in between, 127.9 must be our angle. And that was the corner A. So we've got root 5 and root 104. Sorry, root 45 and root 104. Root 45 times root 104 times sine of corner A. Now, if we think about this, we've got to be slightly careful here because we can't use a calculator. So sine of, well, if we think of the angle as we've got it there, then sine of that angle is the same as sine of this angle here that I've just labelled in, this one. So sine of the 127.9 is the same as the sine of this angle in here. Yeah, same as that one. Okay, now we've got this information. Yeah, that's what we know about A. So we know that the hypotenuse of this triangle is root 130. And this length here is 7. So the height is going to be, by Pythagoras, (130 equals h squared plus 49). So h is equal to the square root of, subtract the 30, subtract 19, is 81. I think I've got that right. So that is 9. Worked out more nicely than we could have hoped, really. And we can now work out the exact value over here. So we can put sine of A in. So you get half root 45 times root 104. Sine of A is times 9 over root 130. Okay, so root 45 is 3 root 5, so we've got 3 over 2 root 5. Root 104 was 2 root 26. Times 9 over root 130. So the 2's look like they cancel. Root 130 is equal to root 5 times root 26. So that's fairly useful, isn't it? Yeah, so the root 30 cancels with the root 26 and the root 5. So the area of the triangle drops out to be exactly 27. And if you've done it using a calculator, the chances are it won't have worked out exact. You may have used the answer button to keep your accuracy very high and got away with it. But really, the working they're going to be looking for is this block of working over here. I've done it in red just to make it sort of stand out at the side of the page. But that's enabled me to get the height to substitute in to find sine of A exactly. I hope that's clear.